Welcome to this introductory video for the structural analysis software RSTAB by Dlubal. RSTAB is a 3D framework program which is appropriate for calculations of constructions in steel, reinforced concrete or timber, plant engineering, and mechanical engineering. With a CAD-like graphical user interface, RSTAB is easy to handle. It doesn't take much time to get familiar with the program. In addition to structural analysis, you can perform dynamic calculations such as analysis of vibrations or seismic analysis. BIM-oriented planning is possible with RSTAB as it provides a great selection of interfaces with other programs. For example, direct interfaces with Tekla Structures, AutoCAD, and Autodesk Rivet Structure. Other available Exchange file formats are DXF, IFC, STP, and many more. The program has a modular structure. Internal forces, deformations, and support reactions are determined in RSTAB, and then the design is performed in one of the numerous add-on modules. New in RSTAB 8 is the automatic creation of combinations. In creating a model, select the corresponding standard and decide if load or result combinations should be created. In RSTAB, you have the possibility to generate models and loads automatically. For example, the generation of a 3D frame. First define the overall dimensions of the frame, and then select the cross-sections for the members from the cross-section database. For this example, I will select an HEA 220 for the columns and the horizontal beams. The 3D frame has been generated with the defined dimensions and cross-sections. By using the copy function, we can quickly create platform beams. From the tools, select the area load generator to create loading on the platform. We see a dialog box for editing load cases and combinations. Here we enter two load cases, self-weight and live load. The second load case will contain the area load on the platform. Now we define the magnitude of the load and select the members to which we want to apply the loading. We can do this by selecting the four corner points around the platform from the work area. Easily deselect certain members from experiencing the load, such as the beams in the X direction. In a similar way, you can also generate snow and wind loading according to Eurocode. As mentioned before, RSTAB automatically creates action, load, and result combinations. To demonstrate, I can define two more load cases, snow and wind loading. Now, four actions are available, from which RSTAB creates automatically, according to the selected combination expressions, the action and load combinations. To modify the properties of objects, select the object and open a context menu by clicking the right mouse button. Or, draw a window around multiple objects to select and make adjustments to the properties of more objects at one time. By selecting the platform beams, I can modify the cross-section of all the beams with just one selection from the cross-section library. Similarly, I can apply the same member and release to each beam. Another way to select objects in RSTAB 8 is to use the Special Selection tool. To select all the columns in this structure, we can click on the button Parallel to Member, and then select a vertical member from the work area. Now all of the columns are selected. We can make a visibility containing only the columns, or make changes to their properties easily. Once again, using the cross-section library to select a new cross-section. All other member properties will remain unchanged. Another new feature of RSTAB 8 is the Views section of the Project Navigator. Here, different views can be saved and activated later with just a click. For example, we can save the current view of just the columns. Then, after showing the whole model, we can use the Special Selection tool again and select all members with a specific cross-section to create a new display of just the platforms. After saving the second view, it is then possible to switch between the two saved views at any time. With RSTAB, you can parameterize frequently reoccurring systems in a simple way. In this hall, some variable parameters have been set, such as the frame distance, the spacing of the gable columns, and the height of the eaves. When these parameters are modified, the model is adjusted in parallel. Also, there's a variety of functions available to parameterize complex models. Loads can also be parameterized. Here, the self-weight of the roof depends on the frame distance. In this way, it is possible to change the value of the surface load, and then the load is adjusted automatically when the frame distance is changed. This user-friendly program offers many more useful features. It is equipped with photorealistic rendering, and is compatible with 64-bit operating systems so that you can perform comprehensive calculations. The program can be operated in 9 different languages, including English, German, French, and Spanish, and the printout report is available in 12 languages. Further information about the structural analysis software by Dlubal and trial versions available for download can be found on our homepage at www.dlubal.com.